Okay, okay, thank God. Okay, well, thank God I just noticed that. Um, okay, cool. So sorry, if you were listening to the YouTube stream, we're talking about account storage right now, so you haven't really missed anything. Okay. So yeah, so right now, like in the blockchain world, when you like store an NFT, for example, or when you like buy an NFT, that NFT is being stored inside your account, right? It's not being stored in the contract, like Ethereum. In the Ethereum world, when you purchase an NFT, all that really means is it's just keeping track of it in the contract. It's just saying this address or your address is mapped to a NFT with like ID 1. This is very different in Cadence, though, because in Cadence, you actually store the asset inside your own account, so you truly own the account. And this is one of the things that Cadence sort of does, is it represents true ownership, or that's the resource-oriented nature of the language. It allows true ownership of assets. So that's one thing that makes Cadence very different from things like Solidity, and in my opinion, a lot better. Okay, so what we're gonna do is let's go ahead and just make like a dummy resource called test. And in here, I'm just gonna make like a public let ID be a uint64, and I'm just gonna say, oh, oops, I don't know why I did that. In here, I'm just gonna say let's init this, and let's just say self.id equals self.uuid. Now, I'm not sure. I don't think I actually have mentioned this to all of you yet, what UUID means. And this probably looks really interesting because you're probably saying, well, what the heck are you saying, Jacob? Like, where is self.uuid? Why is this not giving you any errors? Because we don't see a UUID up here, right? And the answer is, yeah, it's confusing at first, but every resource on the Flow blockchain has something called a UUID field, which is basically like a unique identifier across every single resource out there. So no two resources will ever have the same UUID. Even if one is destroyed, it'll never be made again. So you'll notice that actually it's kind of interesting. If I try and make a field here called UUID, it actually won't let me, because it says cannot declare field here. And that's because it already has something called UUID. You just can't see it. It's like in here, like as a spy almost. So self.uuid is like the unique identifier. And when we get into NFTs, I'll sort of teach you about how the ID of NFTs, I always recommend you set them to the UUID. But anyways, we'll get there in a bit, as long as you know what this is referring to. It's just like a number, basically. It's a uint64. Okay. So then let's make a function called create test. And this is going to return a create test, just like this, all right? So it's going to return a resource. We all know what this is doing. Pretty cool, right? Actually, I'm going to add another thing here called name. And it's going to be a string. And I'm just going to initialize name in here and say self.name equals name. Okay? And of course, now we have to pass in a name here when we create it. And we're just going to do that like this. Okay? So pretty simple. And what we can do is we can go ahead and deploy this contract. Boom, it's now deployed. And we're going to go to the transaction now and start talking about what this means, right? So far up to this point, we've completely ignored the prepare phase. Well, now we're going to talk about it. Also, hey, Shiver, good to see you. Okay, so let's go ahead and log here like I'm done, and this is just going to signify that the transaction worked. But we're going to go into here now. So what does this mean? Well, prepare is really interesting. I think we actually covered this back in chapter 2, but there's a difference between prepare and execute. Prepare is basically the part of the transaction where you can access a user's storage, or their something called their auth account. Now, the auth account on Flow is one of the most dangerous types, because it exposes everything. If you have someone's auth account, you can take anything in their storage. You can withdraw all their assets. You can withdraw all their fungible tokens, all their NFTs, everything. So you never, ever, ever want to expose an auth account, but you have access to it inside the prepare phase of a transaction, because this is the person who signs the transaction. So to prove this to you, let me log signer.address, I think it's called. Yeah. And let me sign this with account 1. So let's log this really quick, or send it. And we get 1, right? But if we send it with like 4, then we're going to get 4. So this is always the person that is signing the transaction. And as an example of this, let's say you let's say you go to Rarible, right? And you purchase an NFT, and the Blockto prompt comes up. It says purchase, and you click approve. Your account is going right to here. So this is a great time to sort of talk about like the security of transactions and knowing which transactions are malicious. You can always look inside the prepare phase to see if someone is messing around with your auth account, and if they're trying to withdraw assets, you can take a look at that. So this is, obviously, this is fine because all we're doing is logging the address, but you never want to see this being passed around. And one of the big things that we look at in Shield, which is like our auditing service, is if there's ever a transaction where the auth account is passed into the contract, it's an immediate red flag. That should never, ever, ever happen. And in any contracts that you develop, I would strongly discourage you from ever passing the auth account into the contract, because that you can get you into some dangerous ground. So don't do that. But with that being said, they are necessary to accessing things in our storage. And let's figure out how to actually put things into this auth account to store these assets. So there's actually a really helpful diagram on this page to help you understand what account storage really is. So inside, let's look at this like red box for a second. This is an account, right? So account 1, account 2, whatever. This is an account. Now, an account has two things. It has contract code. So, for example, right here, right, this is account 1. This stores a contract, right? So there's contract code, and we put some example contracts right here. But it also has something called account storage, and that's what we're going to talk about today. So account storage, it may seem tricky, but you'll get used to it at some point. Has three areas where you can put things, right? So the main one, or the most important one, is the storage path. Now, each of these three are called paths: the storage path, the public path, and the private path. These are different areas of account storage that do different things. So the storage path is where all your data lives. So all your NFTs, all your assets, all your tokens, everything you own is stored in the storage path. Okay, so the only person that has access to the storage is the auth account. When you have the auth account, you have access to someone's storage path, right? So again, this means that I could, take stuff out of your storage if I had your auth account, right? But theoretically, I would never have access to your auth account unless I tricked you into signing a transaction. So no would be moving auth account if it's a resource. It is if it's a would be moving is I think what you're saying, Tabcole, is like if someone's moving your auth account around, yeah, that's an immediate red flag. So if someone's ever like passing your sign, like for example, if you did like hello world dot do something and you like passed in like the auth account, like that's a huge red flag. That should never happen. So don't ever, like, if this is ever being passed around as a variable, that's a no. Um, yeah. So anyways, back to here. So the storage is where all your data lives, and that's what we're going to interact with right now. So what we're going to do is we're going to say let test, and we're going to move in a hello world dot create test, right? We made that function, and we're just going to pass in, just for the sake of simplicity, we're going to pass in tabcol, all right, as the name. So right now it's a loss of resource, but what we want to do is we want to store this resource inside the auth account. So let's go ahead and say signer, and this is new, so you don't know this yet. Signer.save, right? And the value that we're going to pass in is the test resource, right? So we move the test resource into the account storage, and then we need to provide a path. So in this case, we're storing it to storage. So we do /storage/ right? This is the path, and then we can come up with whatever name we want. So let's just say it like a my test, okay? So this part can be whatever we want it to be, but we have to remember this in the future to be able to access it again and get it back. But this means that we're going into storage, okay? And then we're going to say I'm done. We saved a resource to our account storage. All right. So let's clear everything. Let's go to account 1, and let's run this really quick. Let's send it. And it says, I'm done. We've saved a resource to our account storage. So right now, what we just did is we took a resource and we put it inside account 1 at this path. Now, remember, way back, or not way back, but I think it was like 2 workshops ago, we talked about the fact that resources can't be overwritten, right? They can't be overwritten. So what do you think is going to happen if we try and run this transaction again with account 1? Anyone have any ideas what's going to happen? Error? Yeah, it's going to be an error. So if we try and run this again, it's going to say failed to save object. Something already exists at that path, right? It already stores an object, so it's not going to be okay. And again, that's because in the second time we run this transaction, it's going to create another resource and try and store it at the same path. But that's not going to work because a resource already exists at this path. So that you can't do that, right? So it's going to actually error and say, sorry, you can't do that because otherwise you would overwrite the resource, and that would be really bad. I mean, could you imagine if you like stored a bored ape at like a certain storage path that's worth hundreds of thousands of dollars, and then you accidentally overwrote it, right? That'd be terrible. So it doesn't let you do that. But what would happen if we ran this from account 4? Who has any guesses? What would happen if we ran this from account 4? And don't be afraid to say the wrong answer. Yeah, exactly, courtside. So this is going to work totally fine. And the reason is because it's a different account, so it has its own storage. So it's totally fine. So if we run this from account 4, you'll see it says I'm done. We saved the resource account storage, so no problems there. But again, if we tried to run it from account 4 again, then all of a sudden we have a problem, right? So we can't do it. So great job, courtside, for that. Yeah, so that's how you store something to storage. Now, what's cool is that if we wanted to store something else, we just got an error for that. But what we could do is we could change the path and say like my test 2. And if we run this from account 4, now it's going to work because now we're storing it at a different path. So it's totally fine. So the other one still exists at my test, but this one now exists at my test 2. And once again, just to confirm, if we ran this again, it would give us a problem because something already exists at this storage path. All right. So that is how you store things to storage. Now, the next thing we're going to learn is how you withdraw something from storage. And also, we're going to come back to public and private in a second here. But let's just call this save, and let's make another transaction called load, right? And let's copy this, paste it in here, and we're going to make this time we're going to bring something out of storage and destroy it. So I'm done. We destroyed a resource from our storage. Okay. Cool. Now, which part of the lesson are we on? We are at this part. Okay, cool. So let's try this. And again, we have a signer that's coming in, and we're going to try and withdraw something from this storage and destroy it. So let's say let test, and we're going to withdraw something and say signer.load. That's how you bring something out of storage. You load it. And the path is going to be /storage/my test. That's where we think something exists. And one thing we have to add here is this is kind of new, but you have to add these 2 little angled brackets. And in here, you have to put the type of what you think is going to be withdrawn. All right. So we think because, we're humans and we're able to, guess that because we just stored a hello world.test into storage right here, we should be able to load it that type right here. Okay. And then afterwards, we're just going to destroy test. But before we destroy it, we're going to log test.name. All right. Oh, and so look at this. It says value of type hello world.test has no member name, but this is an optional type. Now, the reason is because it's actually this type right here is actually optional because something might not exist at that path. So we can add a panic and say, wait a minute, if we're panicking, then nothing exists at that storage path. All right. So pretty cool. So let's try it. Let's run this from account 4 because we know we just stored something at /storage/myTest, and we also know it's this type. So if we run this, we get tabcol, and I'm done. We destroyed something. We destroyed a resource from our storage. Now, it might be obvious at this point, but what do you think is going to happen if we try and run this right again with account 4? Anyone have any guesses what's going to happen? Yeah, exactly. Yeah, so just like Courtside said, there's nothing there anymore. So it's going to panic. It's going to say nothing exists at that storage path. So let's try it again. And if we send it, it says panic, nothing exists at that storage path, right? Because we just destroyed it in the previous transaction. So it's no longer there. And one thing, by the way, that we can check also is if we made this like a string, for example, and just did this, right? Let's see what happens if we run this transaction and make it a string. Let's send it. Oh, well, it says nothing exists there, but let's let's go ahead and save something again to account for, send, and then let's try and load it. Let's see what happens if we. I'm actually curious. I'm not entirely sure myself, but if we send it, okay, yeah. So look what happens. So because we know that a test resource exists here, but we're telling Cadence we're supposed to be a string, then look what happens. It unexpectedly found a non-string, meaning it found a test resource while force casting the value. So it won't work. So the type has to be correct. So of course it won't let me undo because the playground is just so helpful and amazing. But if we were to withdraw it again, um, log test.name and then destroy it, this is going to work because we just stored something there again. So it will, well, the playground's being stupid. Um, but there you go, right? Boom, it withdraws it and destroys it. So that is how you put something into storage and how you take something out of it as well. Um, Now, this sort of goes back to what we were talking about in the last workshop, but this is obviously super annoying. If we want to like read, for example, like let's say we want to save a test into storage and the name is going to be tabcol and the ID is going to be its UUID, then what happens if we want to read the name of a resource in our storage? Well, the trick, what we'd have to do right now is we'd have to load it from storage, log the name, and then save it back, right? And that's super annoying. But does anybody remember what was the thing we talked about in the last workshop that allows us to do or read information about something but keep it where it is? Anyone remember what that topic was? And that's what we're going to go into next. So I'm going to set that up and see if anyone remembers what that is. Yeah, Numini got it. Yeah, so great job, Numini. It's a reference. So instead of having to save it, and then in the future, if we want to read the name, we'd have to load it, right? Read the name and then deposit it back. What we can do is just use a reference. So we can get a reference to something in storage, log the name, and then we don't have to move it back anywhere because it stayed in storage the whole time. So if we say let test equals signer dot, and what we're going to do now is we're going to say signer. Actually, I'll just do the whole thing over again. We're going to say signer.borrow, right, from /storage/my test. And we have to provide a type as well. But this time it's not a at because that's a resource. It's a reference to a hello world.test. And then we can panic and say if nothing exists there, then nothing exists there. Okay. And then what we can do is we can log test.name, and we no longer have to deposit it back into storage because we never moved it out, right? We're just equaling a reference that something exists in that storage. So let's go ahead and run it with account 4. And it failed because nothing exists there because we destroyed it on the previous step. So let's go ahead, let's save another resource to that point in storage. Boom, we did it. Now when we borrow it, it should work. So let's send it and boom, we get tabcol. I'm done. Oh well, that's the wrong thing. That should say I'm done. We read the name of our resource, right? Let's clear this all again, and we can run it. And the cool thing right, is that we can run this as many times as we want because it's staying in storage. We're not doing anything with it, but we're just simply reading the name and then logging this success down here. So yeah, so that is saving, loading, and borrowing from account storage. And that's it for chapter 4, day 1. And I believe in the next one, we're going to go into public and private paths and capabilities, and then that's actually going to be all there is for today. So anyone have any questions about what we just covered? No? Okay. Cool, cool, cool. So I'm hoping that everyone's doing all right. Um, that is saving, loading, and borrowing. Okay, cool. So, yeah, so what we're going to dive into now is capabilities. And capabilities are, not going to lie, very confusing. And in fact, I actually put a little note here that says this chapter can get very confusing. So, if I lose you during the next half hour, I'm sorry, but it's confusing. And in my opinion, like you're not going to understand it in this workshop. I mean, you might, but I think that in order to truly understand it, you have to play around with it. So without scaring you any further, let's keep going. And again, like this kind of stuff, it's like once you get used to it, like it's very easy. Once you get used to it, it's just that at the beginning it makes like literally no sense. But let's try our best to to do this together. So I guess like the best way to introduce capabilities is to say like, okay, we have something in storage. Now, the issue with this is that right now, right, if I store an NFT to your storage, right, and it has a name, tab col, and it has an ID, let's say 1,273, I don't know, random number. Um, how do I then read information about your NFT, right? How do I look in your account and see that an NFT exists there? Right now, I can't. And does someone mind explaining to me really quick why, like, just based on what we've learned so far, why can't I go into your account and read your NFTs? And it could be like a super simple explanation, but does anyone know why I wouldn't be able to go in and read your NFTs? Yeah, exactly. So I think what MPI you're trying to say is that I don't have your auth account, right? And that's exactly correct, right? Because the auth account only ever appears in transactions. And so number one, I wouldn't be able to read it in a script because I never have your auth account in a script. And like the second point, which is even more important, is that I don't have your auth account anyway because I don't have access to that, right? Only you do when you sign a transaction, or whatever DApp, whatever DApp or transaction has access to your auth account when you sign that transaction, right? So I can't get your auth account unless I like tricked you into signing a malicious transaction. But obviously, we're not going to do that if I just want to read your NFTs. So we need a different way to get to your NFTs. But the NFTs still lie inside your account storage. So how do we do that? Well, the answer to that is this public path, right? And you can see here that this is available to everybody. So if we review these, let's say storage is only accessible to the account owner with auth account, and we use save, load, and borrow functions to interact with it. Public is available to everybody, but private is available to the account owner and the people who the owner gives access to. So, spoiler alert, we're not going to talk about private too much because it's definitely not suited for a beginner course. Um, but basically, the most we're going to say about private is that it's almost like a key. So it's like the account owner can give a key to someone else to access something, but the only people with the key can access it. So that's kind of what private is. But that's the most we're going to say about it. And when we do a more advanced course, we'll dive more into this one. But for basic functionality, public and storage are by far the most important. So, anyways, how do I allow you to read information about my, assets, right? So this is done entirely through capabilities. So what I'm going to do is let's go to here, and This is going to confuse you at first, but again, just stick with me. What we're going to do is something called linking. Now, let's do signer.link, okay? And what this is going to do is basically make it so we're going to take whatever is in our storage and we're going to quote unquote link it to a capability, and that capability is going to be accessible by everybody, okay? So let's go down here and say this link is going to link whatever is in the storage path target and put it in a public path where everyone can read it in the form of a capability, okay? So again, I know this is confusing, but we'll get used to it. So the target here is the storage. So what is it that you want to link to the public? Well, we want to link whatever is in /storage/my test, right? We're trying to make our test resource available to the public right now. So to do that, you put where it's actually lying in your storage. And then here's where you put a public path. And this is where you want people to be able to read your asset. Now, usually these match up. So just for the sake of simplicity, if something is in your storage at my test, you're going to make it available at /public/my test so that people can go here and read this one. Now we have to provide a type as well for what you want to expose. And in this case, we're exposing a reference to a hello world.test. Okay. So again, I know this is complicated, but we're basically saying is whatever is stored at our storage/my test, we're going to link that to the public, and the type of that's going to be a hello world.test reference. All right. So now after we run this transaction, anyone's going to be able to go to this link, this path right here, get a capability, and then read this type. So let's go ahead and let's redeploy the contract. That way, all the account storage is reset. Those of you that don't know, when you deploy a contract, all the storages are reset. So at least like in the playground. So we're going to go back to saving, and we're going to run this transaction. Let's just do it with account 1 to make things easy. So let's send this, and it says done. Okay, so we made a resource, we stored it at this storage path, and then we linked it to the public right here. So let's go to a script, and let's try and prove to ourselves that we can actually read this NFT without having the auth account. So let's type in an account right here, and this is going to be an address. And what we're going to do is try and read this asset. So I'm going to show you the steps in order to do that. So step 1 is we need something called a public account. So whereas an auth account is only something the account owner has access to and allows you to read /storage. A public account is available to everybody and allows, I'll put it in parentheses to match the pattern, and allows you to read /public. Okay, so we're going to get the public account of this account, right? So let's say let public account equals, I'm going to change this to like address, I guess. You call get account and then address. Now this gets the public account. So it's actually a type called public account. All right. So get account of address gives you a public account, and then what we can do is say let test reference equals public account. And now this is where things get tricky, but you kind of have to just watch me do this. We're gonna first get a capability, and it's asking for the path. So a capability is something that's reading from the public path. So when we saved it, we linked this to /public/my test. So we're gonna get it from that path. Then we're going to just .borrow it. So we're going to borrow the reference. And in here, we're going to put the type of it. So it should be a hello world.test, right? That's how we linked it right here. We linked it as a hello world.test reference. So back in our script, well, first of all, we have to import hello world. Can't forget that step. So we borrow it. And then if it's nil or like it doesn't exist at that path, we're going to panic and say there was no public capability here. Now, theoretically, we now have a hello world.test if all this worked, and we should be able to return test reference.name, and we're going to return a string here. So let's try it. Let's try it, right? Let's type in account1 here and see if we can read the name. So let's execute, and boom, we get the answer. So you see, we just got tabcol because that exists in their storage. But they linked it to the public, so it allows us to see it, and we just saw it by doing whatever the heck this complicated thing is right here. Now, again, if we tried to go to like account 2, for example, obviously this isn't going to work, right? There was no public capability here because account 2, not only do they just not even have the resource in general because we never stored their storage, but they definitely don't have a public path that's exposing it anyway because it doesn't even exist, right? So what we can do just to test something, let's go to account 2 right now, and let's link. Let's not link it. So I'm gonna comment this out, which means that this piece of code won't run. So all we're gonna do with account 2 is we're gonna create the resource and then save it to storage. We're not gonna link it to the public. Okay. So let's go to account 2. Let's send it. Okay, it worked. We just saw that it worked. And let's go back to our script and try and read it from public path. Now, who thinks that this is gonna work? Anyone? Let's get some yeses or nos. I'm gonna put a thumbs up in the chat, and if you think this is gonna work and we're gonna be able to read the name, thumbs that up, and if you think it's not gonna work, thumbs that down. All right, so everyone's saying no. So you're all correct. This is not gonna work, and the reason it's not gonna work, well, let's just try it first. Boom, it did not work. And the reason it didn't work is because when we saved it to account 2, we did not link it to the public. Okay, but let's comment these pieces of code out, right? Because we already created it, and let's uncomment out this one now. And this is just going to say, okay, let's take whatever's in our storage and let's make it available to the public. So we're going to sign it from account 2 now, right? And what that did is it made it available to the public now. So if we go back to our script and try it again, now it's going to work totally fine. Pretty cool, right? So an account truly has autonomy over who can read their assets and who can't. And just in case, I actually didn't even include. Did I include this? No, I didn't even include this in the course. But if you want to get fancy, you can use something called unlink, and it's actually really. I think it's actually pretty simple if I'm not stupid. But you can unlink it. So I'm not actually. I don't do this often. But if we try this, let's unlink it really quickly. And let's go back to our script, and it should fail now. Yep, and it does. Because account 2 was like, you know what? Nah, I don't want you to read my assets anymore. So they unlinked it. And now you can't see it anymore. Right? So that's what linking does. And basically, like, capabilities are confusing because capabilities are basically like a middleman. It's like you have storage, and then you have capabilities in the middle, and then you have public paths, and capabilities are like the link between the two, but they're only there if the account told you it can be there, right? So that's sort of the trick with capabilities. So yeah, um, that's that. So any questions about that before we get into like the final part of the course? Or sorry, not the course, the workshop. Where is all this storage taking place? That's a great question. Oh, well, because we're on the playground, this is all just local. Because this isn't like this is all just on like a local emulator, which means that like none of this is impacting the blockchain at all. But like if you were doing this on like mainnet, then yeah, like all this storage would be on chain. Yeah, no problem. Cool. So okay, so now if we didn't have enough problems already, we run into another problem. And the next problem is, well, how do I only expose certain things and not other things? Okay, so what do I mean by that? Well, right now, inside of here, what if we had a function called change name? And it took in a new name, which was a string, and it said self.name equals new name. Now, of course, it's make var, right? But what if we had this kind of contract and we redeployed it, confirmed it? Okay, thank God. So we redeployed it, right? And we went into save again, and we were like, you know what? We want to make sure that I have to link this again. Hold on. Um, okay. So we want to link this to the public. However, right, we want to make it so the public can read the ID and the name, but they cannot change the name. And that's the current problem with the system we have, because what's happening right now is we're linking the whole reference, right? If someone has a reference to a hello world.test, you can be dang sure that they're going to call this function, right? Because they can. So, does anyone have any ideas? We actually talked about it in the last workshop, but does something exist that allows you to access certain things but not other things? What was the topic of the last workshop? Yeah, an interface, right? So, remember I said in the last workshop that like we had no idea why we were talking about interfaces. We were just learning about them. This is exactly why interfaces come in helpful. So we can make a resource interface called iTest, and in here only include the ID and the name, just like that, right? And then make this implement iTest. Now, when we do that, if we redeploy the contract again, okay, what we can do is when we go to save it, we're not going to expose this type. We're going to expose that type restricted to hello world.itest. And boom, we have solved our problem. Well, if the playground wants to be nice, that is, but we have now solved our problem, because what's going to happen is if we go ahead and run this transaction, let's send it, and it says, I'm done. We saved a resource to account storage. Let's go to our script. And first of all, this isn't going to work anymore because this type is wrong, right? This type is not right. It's now the public capability now has this type, that I test, sorry. So of course it's going to allow us to to return the name. But what's going to happen if we try and do test reference dot change name? Uh-oh, member of restricted type is not accessible, change name, right? It doesn't work. We can't do this. Now, of course, obviously, yes, it wouldn't work because it's in a script and you can't change data in a script anyway. But imagine we were doing this in a transaction, right? You wouldn't be able to call this function because it's not in that restricted field. So this doesn't work. But we can still read the name because hello world.itest includes the name, right? Um, so yeah. So if we were to run a one here, it would execute and boom, it's there, totally fine. And some of you may be wondering, well, what if I just didn't put the restriction here? What if I was like, you know what, nah, screw you, Cadence, I'm going to borrow this anyway? Well, you're going to get screwed because it doesn't work, because there's no public capability here that matches this type. You have to put the type that exists, and it's this one. So it's impossible for you to try and hack the system and access a function that's not available. So if we, I sort of like to tie these examples to the real world to help you understand. Think about an NFT collection, right? In the real world, you have an NFT collection inside your account storage. And I don't know, let's just say it exists at like /storage/ go to goats collection, right? Um, and so what's happening is when you set up your go to goats collection in your account storage, you also link it to the public. But there's a reason why people can deposit to your collection, but they can't withdraw. And that's because when you link it to the public, you're only linking an interface that allows you to deposit, but doesn't allow you to withdraw. So that's sort of the behind the scenes of how that's working. And next week, or actually starting tomorrow, starting on Friday, we're actually going to start building our own NFT contract. So yeah, I hope that gives you like a little bit of insight into how that's working. Oh, one more thing I want to talk about. So before we, like I said on Friday, we're going to be diving into NFT collections, which is a whole other like sort of topic. But does anyone see any current issues with like trying to store a bunch of NFTs to a storage path? It's kind of like a hard question, I guess, but like I wonder if anyone's been thinking about that in the back of their head. Like, doesn't it seem weird that each resource has to be at its own storage path? Because then theoretically what you're telling me is that every single NFT can't like has to have its own path. And like that's super super annoying. Um so the solution is to have a resource called a NFT collection and put that at like /storage/NFT collection, and then you deposit all your NFTs to that collection. That way everything exists at one storage path. Um So yeah, that's we're gonna talk more about that on Friday. But I'm gonna pause and see if anyone has any questions. And if not, that's all the topic we have or the topics we have for today. So Courtside says, how do you find all the available paths? That's a great question. The answer is you can't right now. And in fact, that's exactly why you you want an NFT collection, because if you don't have a collection, you would be storing them like, let's say /storage/goated goat 1, and then goated goat 2, and then 3, and then 4, and then 5. But the problem is that dApps don't know that, right? They don't know that something exists there. So the way to do this instead, is to have one thing. What the heck? Is to have one thing stored, and you would call this goated goat collection. And inside this collection exists all your NFTs, right? And so then you would be able to borrow a reference to a go to go collection and then call a function called like get all NFTs, and then it would like return all the IDs. But that's sort of why you don't want to like you want to store things at storage paths that are almost like standardized, right? That the dApps know exist instead of just like random paths. Also good question, Courtside. So the way that you would know that in someone's account is you would call a script. And usually the best way to do that is to try and get a capability to it. And if you can't get the capability, for example, you panic here, that means that you can't that means that it doesn't exist. So I will try and show you, let's say a check setup. So what we're gonna do is we're gonna make a transaction that dApps would do to set up your actually how would they do this? Yeah, they would probably do it in a script. They would say, okay, they would take your address and they would say, let's get your public account, and then let's get a capability to, let's just, okay, this is going to give a bunch of errors, but stick with me. Go to goats.collection and then go to goats.iCollection, right? And instead of panicking on this line, they're just going to say um, return this does not equal nil, and then we return a bool. So this is how someone would check if you have it correctly set up in your collection. Is you would get their public account, you would say public account.get capability to like /goated goats collection. You would try to borrow the public reference, and if that equals nil, then you return false, and if it returns true, then then that means they're set up correctly. So it's really a matter of like trying to check capabilities that should exist, and if they don't exist, then you know they weren't set up correctly. You know what's actually really interesting though is all of you are the first sort of cohort of the boot camp where there's actually been a pretty crazy change in cadence where you can actually get someone's auth account in a script. Um, Now this sounds scary that I could just get your auth account in a script, but think about what a script means. You can't change any data. So I actually in a script, I'm not sure exactly what it's called. I think it's like think it's called like get auth account. I think it's this. But yeah, it's called get auth account, and this is a function. It doesn't exist in the playground, but it exists on mainnet, where you can actually get someone's auth account, and then you can withdraw, you can borrow, you can do whatever you want, but it doesn't matter because it's in a script anyway. So technically, you could also just, instead of getting a capability, you could just borrow directly and say, okay, just borrow go to goats collection like that. Yeah. So this is actually much easier, and you just say auth account. So return auth account.borrow, check if they even have a go to goats collection, right? Screw capabilities in public, whatever. And if that does not equal nil, then we're set up correctly. Yep. All right. So that's all I have for all you today. Um, any more questions? No, I think for some reason I think Flow mainnet might still be. Yeah, I don't know what's going on here, so I'll have to check that out. Yeah, exactly, Tab Cole. It's sort of like utility for projects, to be able to like understand what assets exist in a collection, and there's another reason for it. It's kind of confusing, but I'll try to explain it anyway. Um, there's a massive problem that exists in Cadence right now, where some people don't set up their collections correctly. So what I mean by this is, try to imagine, right, that NFT collections have to implement multiple interfaces. They have to implement like a standard one that all collections have to implement. They can implement their own interfaces that they make themselves, right? And it's up to people who set up their collections to make sure that they link them properly to the public. Now, one issue is that, you know, once sometimes, like I'll give you an example on gotogoats.com. If you connect your wallet here and you go to collect, for example, if you haven't initialized your collection yet, right, you can click Initialize Collection. And let's actually take a look at this, for example. So this is all the Cadence code. We can actually copy this and bring it over. Let's copy it. Um, I don't know, maybe this is getting out of scope, but we'll try it anyway. So, wait, what? Okay. So, yeah, I mean, obviously there's going to be a crap ton of errors here, but let's just try this anyway. Um, So in this transaction, they're trying to set up your go-to-goats collection. So they're saying, okay, if the account is the signer here, so if signer.borrow go-to-goats collection from a storage path equals nil, then set up the collection, right? And they're also trying to link certain things, right? So if a capability doesn't exist that should, you link it to the public, right? So there's a lot of complicated stuff here, but the main point is that like when they're setting up your account, they're trying to make sure it's set up correctly and that proper things are linked with certain interfaces on them. Certain collections are created, all that, right? The issue that I'm trying to get at is that Blockdo or third-party services allow you to set up collections. So when you go on Blockdo, like the app, you can set up a go-to-goats collection by clicking that plus button in their app, right? The issue is that they often do that wrong, and they set up people's collections the wrong way. And a lot of third-party services do this actually. Like for example, Rarible like completely sets everyone's accounts up wrong, but like no one talks about that. So it's like really problematic actually. Not in the sense of like security, but in the sense of like other dApps that are trying to read information about your collections have a really hard time doing that because sometimes they're set up wrong. Um, and so the reason that this actually was introduced, like I know I just told a long story. The reason this was actually introduced was to allow good acting dApps, like people that know what they're doing, to like basically take people's collections that were configured the wrong way and manually configure them the right way to read assets the right way. So I know that's like really confusing, but that's the main reason this was added. So that even if your go to ghost collection was set up wrong, I could in this script set up your collection the right way, read your assets, and then it would just go back to normal anyway. So I hope that made some sense and some insight on why they introduced this function. Quartz, Quartz, I can't stand the new block app. Yeah, yeah. You know that's interesting, Quartz. I guess I've never had like a problem with it. I think. Wait, let me actually check. I think yeah, like when I log into the Blockto app and I go to the wallet tab at the bottom and I click collectibles at the top, that's where all my like collections are. And you can click that like plus button to like add new collections, but um it's not intuitive for someone that doesn't understand cadence. And I think that now all of you probably have a better understanding of why NFT collections are so annoying on Flow. It's because you have to manually set them up every time to even be able to store them. Actually, we're gonna learn a lot more about that on Friday, but that's sort of like a kind of why. It's like on Ethereum, you can give someone any NFT you want, but on Flow, you can't give someone an NFT unless they set up the collection. Yeah, exactly. It's because what's happening is they're storing a collection in your account, and then when you store the collection, you can deposit NFTs to it. But you can't deposit an NFT to someone's account storage if they don't even have the collection, right? Should we do any background research on Blockto? Oh, no. Don't worry about the MPI. That's totally fine. No, don't worry about that at all. It's more of just like an example, but you don't have to worry about that. All right. That's all we have. We're almost out of time here. Sorry I can't give a float out. I think Flow mainnet is down right now. In fact, I think I saw an announcement earlier today that they were doing a spork. So I guess we'll have to wait for that to be done. I'll check out the problem anyway, and I'll see you all on Friday. And we're gonna start making our own NFT contracts. So get excited for that, and we're gonna learn a lot more as always. So thanks everybody, and peace out. Have a good rest of your week. Next time we see each other will be TGIF. Double floaties on Friday? Yes, sir. Bye, courtside. Bye, snowmobiles. Thank you. Thanks, Crypto Chica. And also always thank your instructors, everybody, for doing such an amazing job. Bye, Emma.